Welcome to Spring LIB.
Our question wants us to consider a bulb that's emitting wavelengths of light at a range between 360 nanometers and 2000 nanometers. Assume that the light is incident on a diffraction grating with a slit spacing d, and that the first order brightness maximum for the wavelength of 1200 meters or 1200 nanometers occurs at an angle theta. What other wavelengths within the spectrum of the incident light will produce a maximum brightness fringe at the same angle theta? Well, the equation that tells us the diffraction grating with the condition of the maximum brightness at normal incident is d times the sine of the angle theta. So d is the distance between the diffraction grating slits. D sine theta is equal to m times lambda, where m, of course, is the order of the maximum brightness fringe, and lambda is the wavelength at which that diffraction occurs. We're told that when m is equal to 1, because it's the first bright fringe, that lambda is equal to 1200. So we have here is our starting point where d sine theta is equal to 1 times 1200 nanometers, or that equals 1200 nanometers. But this is just when m is equal to 1. So at the exact same value of the angle theta, other maximum brightnesses are observed at different values of m, which would have different wavelengths. So we can also set this equal to, this is still equal to m lambda, as we see above. So what about when m is equal to 2, right? Well, actually, let's go ahead and rearrange this equation first, and then we'll start plugging in values. So we get a wavelength. We'll call this wavelength lambda sub m for different m values, because m has to be an integer of 1, 2, 3, 4, 5, and so on. So this is going to be 1200 nanometers divided by m. Well, we already know that the 1200 was when m is equal to 1. So now let's test out some other values. What about when m is equal to 2? Well, you simply plug that into our expression. We have 1200 divided by 2. So lambda sub 2 is 600 nanometers. This is within the range we were given, since our range was 360 to 2000 nanometers. So we can go ahead and box this in as a solution of possibility here. What about when m is equal to 3? Well, you plug 3 in, and you end up with 1200 divided by 3. So lambda sub 3 is 400 nanometers. Once again, 400 nanometers is within our range of 360 to 2000 nanometers. So 400 nanometers is a possibility and can be boxed in. Let's keep going. Let's try another one. How about m is equal to 4? Well, when m is equal to 4, we have 1200 divided by 4, which gives us lambda sub 4 is equal to 300 nanometers. But 300 nanometers is outside of the range that we were given of 360 to 2000 nanometers, so m equals 4 is not a solution.